When your Luna HSM goes into production, good enough security isn't enough. In this topic, we'll turn secure coding habits, strict access control, hardened configurations, and detailed audit logs into a practical, compliant playbook for protecting your most sensitive cryptographic keys. You've already seen how Luna HSMs are built, how clients connect, how keys live and move, and how real applications call crypto operations. Now we shift to production reality, locking down those integrations, demonstrating compliance, and getting ready for testing, monitoring, and troubleshooting. When you integrate with a Luna HSM, everything should be guided by 4 security objectives. First, key protection. Private and symmetric keys must never be exposed, copied, or misused. Second, access control. Only explicitly authorized applications, users, and services reach each partition. Third, accountability. Every administrative and cryptographic action is logged and can be reviewed. Finally, compliance. Your configuration must reflect your policies, regulatory obligations, and risk appetite, not just vendor defaults. Least privilege is your first real control against misuse of an HSM. Think of 2 tracks, applications and humans. Each application should be tied to a single partition and only the keys it actually uses. No shared passwords, and no one credential for every environment. For people, use role-based access. Operators, developers, and admins get different rights, strictly tied to tasks. Then schedule regular reviews and aggressively remove anything that's no longer needed. Strong HSM security also depends on separating duties, so no single role can do everything. Administrators handle appliance setup and maintenance, but they don't use application keys. Developers and application operators run crypto operations, yet they can't change security policies or manage the hardware. Sensitive actions like key creation, deletion, backup, or policy changes should require dual control. Independent auditors review logs and configurations, but only with tightly controlled, read-only access. Think of each partition as its own mini HSM with a strict purpose. A code signing service should never see payment keys, and payments should never see test or dev keys. Map applications to dedicated partitions based on ownership and environment. Lock each partition with its own authentication and policies. Document which services and key objects live where. That way, a compromise in one area doesn't cascade into cross-application key exposure. An HSM is only as strong as the credentials that unlock it. Hard coding pins, passwords, or challenge secrets into code, configs, or scripts turns every repository and log into an attack surface. Instead, store all HSM credentials, client certificates, and trust anchors in an approved secrets manager with strict access controls and auditing. Rotate these credentials regularly, and always after suspected leaks or team changes. Now think of HSM use as a strict session lifecycle. You initialize the client, open a session, and authenticate with credentials that never appear in logs. Then you perform cryptographic operations using handles or labels, but avoid printing key names or attributes. If a PKCS number 11 call fails, return a sanitized error that reveals nothing sensitive. Finally, always close the session and free resources so you don't exhaust connections or leave stale authenticated state. The Luna client is part of your HSM security boundary. Start by hardening the host. Patch it, lock down OS access, and treat it like a sensitive server. Restrict client files and libraries so only trusted admins and service accounts can touch them. Lock network paths so only approved application hosts reach the HSM, and enforce mutual TLS with certificate checks. Then remove sample configs, test credentials, and unused tools. Key attributes act as guardrails. For each use case, you want the minimum capabilities needed and nothing extra. A code signing key should only sign. It never decrypts and it stays non-extractable. A TLS private key may decrypt and sometimes sign, but it shouldn't wrap or leave the HSM. Data encryption and wrapping keys follow the same pattern. When you right-size attributes, you shrink the blast radius of any compromise. Audit logging is your evidence trail for everything sensitive that happens on the HSM. Capture every important event, admin logins, failed authentication, key creation and destruction, and any policy or configuration change. Write those events to secure, tamper evidence storage with clear ownership for reviewing them. Then apply retention rules so logs stay long enough to meet regulations and to support investigations, alerting, and incident response. To get real value from HSM telemetry, you need to see it in context. Forward HSM and client logs into your central logging or CM, alongside application, identity, and network events. Then correlate. For example, a key export with a new admin account, or repeated auth failures with a suspicious deployment. Use that context to drive alerts, dashboards, tickets, and reports, so HSM activity becomes part of everyday security operations, not an isolated specialty. Compliance mapping is about making every HSM control traceable. For each control, decide which framework it supports, what evidence proves it, and who owns that evidence. Audit logging might feed a CM export, key attributes produce configuration reports, and role separation appears in access review matrices. Capture this continuously, not just before audits, and verify the artifacts match real configurations and behavior, not just what your policies say should happen. Luna HSM security should be treated as an operations loop, not a project you finish. Regularly review who and what has access, especially partitions and service accounts. After any upgrade or infrastructure change, revalidate configuration baselines. Continuously analyze logs and alerts for anomalies, then adjust or tighten controls. Document decisions, ownership, and evidence, so audits, incident response, and future reviews all start from a known, trusted state. For Luna HSM integrations, focus on 4 habits. Control who can do what, with strict least privilege and clear role separation. Harden clients, hosts, and key policies. Centralize and protect audit logs. Next, we'll test these controls and troubleshoot issues, turning designs into proven, resilient security.